and welcome again to my workshop. Today we're going to do a 4th axis ArtCAM tuition. What I'm actually going to do is I'm going to draw an object in ArtCAM and show you how to manipulate it into a 4th axis. I think I'm going to split the videos up into 2, so we're going to do the ArtCAM video for this one, and then the next video will be actually cutting it on the 4th axis in the Pacific tooling machine. After my last video where I showed you how to set the Pacific tooling CNC rotor up with the 4th axis, I got quite a few emails and a lot of, shall we say, the professional guys were suggesting to me that it was the wrong way to do it, and that it should be set up in Mach 3 in degrees angle. That is true, but in the real world, what a lot of us do, and I say us because I've done it myself, and you can use NC Studio and Mach 3 for this. The programs and the machine itself doesn't understand, it doesn't know whether it's flat or round. So when you put a file which is normally written in the x-axis and connect the 4th axis up, or the rotary axis up in the X driver, which is the normal thing to do, you have to carry out the type of setting up in Mach 3 what I showed you in my last video. And it's a very simple process to do. It's a very easy process. There is a facility in Mach 3 to use the x-axis as a slave axis in the rotary axis and link it up in Mach 3 and then put the radius measurement in, and Mach 3 is supposed to set the driver then up correctly. Well, sometimes it does, sometimes it doesn't, I've found. So, and a lot of other people have found that too. It's not as easy as it sounds to do. So what I'm going to do in ArtCAM is I'm going to put together a 3D relief, and we'll write the G-codes for that, but I'm also going to wrap it into a 4th axis, and the ArtCAM program which I have, which is ArtCAM Premium, will put a 4th axis output, so you can connect it directly into Mach 3. But I'm going to show you the simple principle of connecting up the X, or disconnecting rather, the X drive and connecting it to the A axis. So slaving the 4th axis or rotary axis instead of the x-axis. That is the most simplest way to do a rotary job, should we say, on a CNC rotor. Now then, some of the emails, not emails, but some of the comments as well that you will see describing to me that I was doing the wrong thing. These are people which normally use a rotary axis in something like a Toolpath mill, where high precision is absolutely necessary, and I totally agree with them. But with CNC rotors, and you're cutting wood and aluminium, you're not actually making gears and things like that. 0.1 of a millimeter is close enough. You know, it's a few thou. So it really comes to the point where it doesn't really matter. So we'll get on, and this particular video I'll show you how to put something together and eventually wrap it into a rotary axis in ArtCAM. Right, so what we need to do first is open up a new model like this, and we're going to set it at no, not that bigger. I'm going to go 315 and 315. Now then, why I've chosen 315, there's, as near as damn, 315 millimeters around the circumference of the diameter of a cylinder that is 100 millimeters or 4 inches in diameter. So that is why I've chosen 315 millimeters, and it's to make it nice, a nice square flat picture. I've actually chosen 315 in the Y as well. Now we need to change this because I've got the actual motor at the front here, and the head, and the material is going to run this way in the table. So I want to come in from this end. So, and I want to make the start here. So don't forget, this will be wrapped around the Y in our case, but we're using the X axis to operate the fourth axis. So the X axis is just going to be motionless, and the Z is just going to go up and down like so, and the Y is going to, the X is going to rotate the piece of material, and the Y is going to move the material further into the cutter. So that's our setup. So we're going to, this is okay, this is midway, set midway, this is just fine. And we're going to okay that. Right, so this is ArtCAM Premium. And to my way of thinking, there's no better program on the planet to do what we're about to do. So here we go. Now, you don't have to have the measurements on here. I have these turned on all the time because I can better align things up, and it's just my way of working. I've also got a snap turned on. If you notice, the cursor will change when we reach the extremities of the material, and it's easier for me to snap a start and finish point of a line or a vector. Now you'll hear a lot about vectors. A vector is just simply a line or a curve. That's what a vector is, and we are going to be dealing with vectors, and we're going to make our own vectors in this piece of work now. We're actually making a 3D relief, a full 3D relief from scratch. So here we go, and we're coming over here, and this is a vector tool or a polyline. Now I want to do a straight polyline or straight vector, which is a straight line. So you must ensure this is not ticked, otherwise it's going to give you a wavy line. So we just come here and go from here to this corner and right click, and back here again to this corner and right click. Now then, I've just drawn two lines, one at the top and one at the bottom. Within ArtCAM, these are what is commonly known as drive rails, and it is really exactly what the description says. They're rails, they're directional rails. It gives ArtCAM an indication of what path you want to go down, because we're going to sweep across the front of this with a shaped vector, which we're going to draw in a minute, and these lines are the rails that we want to follow down, and within ArtCAM they're called drive rails. Now then, what we're going to do is come over here again. This time we are going to click this box, which allows us to do any shape really we wish. I'm going to come up here, which is roughly at the top, and we're going to do a left click. We're going to come down, now we're going to go out there slightly, come out here, and then back there, and then down a bit. Then I'm going to make a bead here, because don't forget this profile, and that's what we're drawing now, we're drawing a profile, is going to wrap around, entirely. And another little type bead here. You can go in and, you just roughly do this first, and then you can edit it. And what we're doing, we're making something, we're actually making a vase. A decorative vase. Okay, so we're going to finish there. And that's quite nice. I think that's going to be quite alright actually. I think we will, oh that's fine, that's just fine. So you can see the general shape now that we've got two beads here, and we've got sort of rounded area here, and here. So now then the next thing we're going to do is come and use a new tool, which I haven't shown you before. Now this is we're actually going to make a 3D relief. Now there's several different methods if you want to make a circular object, like a pancake or something like that, or there are different ways in which you can do this using different types of tooling. But this one is a 2-rail sweep. Okay, it says up here 2-rail sweep. So there's one rail, there's the other rail. So it's very simple to do this. So, and this dialogue actually assists you. So it says to you, okay, first drive rail. Well, this is the first one up here. And we click that, saying this one we've highlighted, we want to be the first drive rail. And it's accepted it. Now we come down here, second drive rail, and this is the vector, okay, the shaped line that we want to pass through this material and cut it, as it were. Add cross section, that's what this is. Okay, so we pull this down, and you could actually add it, you can subtract it, sorry if I can get the word out, and there's our shape. We can subtract it as well if we want to, and it changes the shape immediately. Within ArtCAM you can manipulate a 3D relief live and quick. But we want to add it in our case, and apply. It's done, it's in. And we can cross and get out of that. That is fixed. So now what I want to do, I want to show you something, another thing really different here. And that is, we are going to add a 3-dimensional relief on this, a pattern. We're going to add a pattern onto this. So what we do, we go up into the reliefs up here, and we say, let's choose a relief. Let's have a look, see what we've got here. And there's over 600 reliefs that you can use, and you can use for your business. Many, many, many reliefs. Oh, here we go. We're going to use this one. I'm going to bring it in the bottom here, and this is live, and you can do this live in ArtCAM. And we're going to pop him about there. Now because we're going to wrap this, we want these ends to meet. So the length of this needs to be identical to the length of the material. Otherwise we're going to have a line. So we want to get rid of any type of joining line. We want a smooth transition all the way around. So what we need to do is alter this top one here, the lock's on. So you turn the lock off. Okay, so this is aspect ratio. Okay, so we turn the lock off, like so. So you can click it 3 times. Look, the first click locks the width and the height, but you can still alter the Z. Second click, the 3 are locked together. So if you alter one, the other 2 will alter with it. Now, if you totally unlock it, which I have done there, which is what I require, that's how to do it. So we want this to be the same as the length of our material, which is 315. And so it doesn't go too much out of shape. You know, we want these to stay rounded. So what I'm going to go there is 115. But I only want to I want this to be more of an accent on the piece. I don't want it to stand out real proud, and I don't want it to be the main, shall we say, draw CAD to the piece. I just want it to be subtle. So we're going to say we want that 3 millimeters. And we're going to apply. I'm going to check it, see if that looks fine, and it does. And we're going to come down here and we're going to say we want to, so you can scroll through these as well. Okay, so we want to add it on top of, we've already got made one relief, it's shaped. So we want to add this on top of that relief, and we want it to be added onto the contour. So it's add, okay, not merge high. If I merged high, I'd probably lose half of it, because it would sink into the, because we know that this part is rounded like this, it'd probably sink into the bottom half, and we'd lose half of it. So I'm going to say paste, and there it is. It's only an accent, it's not the main draw CAD of the piece. Okay, so we'll come out of this. Okay, so now we bring out our project tree, and we're going to say we want to machine this. And there's a good reason why I want to machine this, is I'm going to prove to you that indeed the machines don't know whether this is flat or round. They just obey the instructions to move from A to B, the 3 axes simultaneously. So I'm going to take a bit of the mystery out of 4th axes, I hope. So we're going to come down here and we're going to go, okay, we want a 3D toolpath, and we're going to do a roughing cut because there's quite a bit of material to move out, and this one, rough in. And we're actually as well, I'm going to show you how to make a brand new tool and set it up in the tooling list, because this one isn't in here. Okay, wood and plastic, rough in, and we're going to pick the 12 mil, and then we're going to come over here and we're going to say copy. Okay, So we're going to cancel. This is just my preference, the way I do it. Okay, back in and pick the top one, because it's going to be a larger tool. And we're going to go in here and we're going to edit. In actual fact, that's not the one I want. Talking to you guys, I just mucked up. It doesn't matter. Copy. Yes. Cancel. Yes. Back in. Rough in. Because it's a ball bell, I'm going to do the rough in with. So we're going to choose this one and we're going to edit. Okay. So this line here, this is what you see in that tooling list. So it's a bowl nose mill and it's a 19 mil. It's a nice big one. Diameter 19 mil. 12 mil is a little bit too far, so I'm going to put 6 mils enough. But you can change this at any time. Step over. It's probably a bit much. 5 mil is probably preferable. Step over. 15,000 revs, probably burn the material if I left it at that. 12,000 would be fine. These I can alter to suit the material, so I'm going to leave them as they are, because I'm just setting this up in the tooling list only. So I'm going to press OK, and there it is, done. So I'm going to cancel a moment. Okay, so now we're going to choose the tool, and there it is. It's ball mill, 19 mil. So we're going to set this up now to do the job that we want. Oh, I don't. Step over. I don't know what that is there, but it should be 6 millimeter. No, 6 millimeter is a bit much. I think I'll go 3 millimeter. I don't want to tear out any material. Step down. Yeah, 6 millimeter is fair. Now, this PT Pacific tool in 6012 will actually absolutely rip into material and get the job done pretty quick. So I'm going to go 100 or 4 inches a second, which is pretty damn high. And the plunge rate, which is the Z action, I'm going to put 50 as well. 12,000, tool number 1, that's correct. Now then, both directions, that's fine. Not worried about the tolerance, it's only a roughing cut. Add ramp moves, probably. Punch height, yeah, that's okay. This is all okay. ArtCAM preempts what I want as well. As you use the program more, it will preempt more of what you want to do. I'm going to set that a little bit higher than that. I'm going to go 15 mil. I'm going to also set the home the same. Now the material, well, we know it's 100 mil diameter, so it's half of that. So that'll be 50 millimeter. Top of the block. Bottom. Yeah, okay. That's pretty right. So that's that one done. this is just my personal preference too. I always do the roughing and finishing separately. I know you can do it on the same wizard, but I always do it separately. It's just a habit I've got into. Now then, it's a ball mill and it's a 2mm. It's that big long tapered. I'll actually get it and show you. Okay, so these are the tools that I'm actually talking about. This is a tapered ball mill. So it's 6mm down here. Ooh, 6mm down here, and it's 2mm diameter ball down the bottom there. This is primarily manufactured for cutting aluminium. It's a coated tapered end mill. You notice the coating on it. And this one is still a ball mill, but this is a 19mm or 3/4 inch ball mill. Just a word of warning too, if you buy a CNC router with a 1.5 kilowatt motor, it will only take a shank this size, 6mm, maximum size. If you upgrade to the 2.2, it will take 13mm shank, 1/2 inch. So just be warned about that. So this is this tool here that we're going to do now. So we're going to select that one, and okay, actually I have found if you alter that to 0.25, that's adequate. Step down. Actually, what I do with this, I set to 10mm step down. I want to do this in one cut. I don't want to do several cuts. So ArtCAM will know how much material is left there, and it will do it in one cut. There should only be about 1mm of material left. And in fact, I'll go back and check that in a second or two. And this one, plunge. No, we'll do this one first, 100. Plunge, 50. And tool number 2. This really doesn't matter unless you have a tool changer. But it does actually prompt you to change as well. This is all okay, all the same. So this now is a So now at this point in time, I'm going to export the tool paths. If I get myself organized here. Okay. So, and this is how you save now to your memory device. You can, save the whole. Put that away. Now then, I'm going to show you a magical thing, and that is how to wrap. How to make this into a 4th axis. And you come up here simply to relief, rotary axis, create rotary relief. Now, this is fairly important. We want to wrap the X value. Remember that the X axis is going to be slaved to the fourth axis, and we're going to disconnect the x-axis and connect it up to the fourth axis. So we want the wrap x value around the y axis, because our material is going to be up in the y direction like this. It's not going to be across the machine, it's going to be down the machine. So this is the correct one for us. I'm going to say OK. Boom. There it is. Okay. Actually, I'll tell you something funny in a minute. Okay. So here we go. You can toggle it around, and this is the actual object that you're going to end up with. Okay, let's move this around a bit. Hope you can see that. Just something funny that just happened actually live when I was just recording, putting this together in ArtCAM. I just had a customer ring me because the the other team that normally deal with the team that normally deal with problems then that people face. Decided to put this one through to me, I think as a bit of a joke. I just spoke directly to the customer who's taken delivery of his 6012 and informed me that he couldn't couldn't operate the machine, couldn't make the machine go, and he said that he had Mach 3 up and running, and the machine switched on, but it wasn't working. And I just discovered that this customer didn't realize that he had to plug a USB cable into the machine and the computer. Now, I'd just like to say to all the prospective customers, please, if you have, not problems exactly, but should we say setting up difficulties, I have made videos on my YouTube channel of how to set these machines up in general, other people's machines as well, and how to operate them, how to use Mach 3, how to use ArtCAM, and look, I really don't mind doing it, but you can appreciate that it takes up some considerable personal time if I have to sort of deal with problems that can be averted and sorted out for yourself, because ultimately, you know, because we're selling more and more machines all the time, and the machines that we are selling, namely the 6012, the 1212s and the much bigger machines, and most of our customers are professional customers, universities and schools and trade schools now are purchasing in Australia, America, and a lot of other countries as well, Malaysia. So please, if you are having difficulties, first, before you contact one of our team for assistance, have a look at the videos, and you'll see that there's a wealth of information of how to operate these machines, the programs, and problems that I've had in the past with machines and how I've solved them. So, and you know, you learn a lot more by doing the job yourself and having a good look. But in an effort to keep prices down of these machines, because you know, if you come to us with every little problem that you think you're having, this ultimately causes higher resources from our company, and so we have to employ more staff, and ultimately it's going to raise the cost of the machine. So I hope you understand about that, and try and sort it out for yourself by looking at the videos on YouTube, and there's an answer there to any of the problems that's arisen. So thank you for joining me, and I hope you enjoy me for part 2 of this, the machining of this part on the PT6012. Thank you for joining me. Bye for now.